example 6 asks us to express each of the following in terms of the same trigonometric function, but of an acute angle. So that's a key part here. So we need to make sure that ultimately we're going to be answering questions over in the first quadrant, or our angles need to be over in the first quadrant. So it asks us about, what about the tangent of 136 degrees? So we need to do tangent of some number between 0 and 90. So how can we get all that stuff to relate to each other? So let's think about 136 degrees. That would be in the second quadrant over here. Think about what makes tangent. What makes tangent? Tangent is made solely by, or not solely, I guess, by both its y value and its x value. Well, the x value in the second quadrant is negative. So what I need to do is figure out, so how do I relate that to something that's over in the first quadrant? Are they going to have roughly the same tangent values? Are they going to be opposite? Are they going to be reciprocals? What's going to happen? So I'm going to say, okay, well, what if I keep my y and x values the same? What if I draw a line over here? So my y, same value, my x now, sorry, not the same, but I switch it to now being a positive number. What can we say about these things? Well, are the tangents the same? Are they opposite? What are we looking at? Well, since tangent is the same thing as slope, and we look at y divided by its x-coordinate, the yellow one is going to have a negative tangent. The blue one is going to have a positive tangent, and they're going to be exact opposites of each other. So what I need to figure out is, how do they exactly relate in terms of their angle? Well, what I can see is that the angle coming back from 180 degrees, right, which is this over here, for the yellow one is the same amount as coming up from 0 for the blue one. So, but what we end up with is actually opposite answers. So what I have to figure out is, how do I measure how much I went back from 180? Well, the tangent of 136 is the same thing as the tangent of 180 minus 44 degrees. So what I did is I actually moved 44 degrees backwards, right? So what if I move 44 degrees forward? What happens? Well, what you can see is their slopes are opposite. This is the same thing as the opposite of the tangent of 44 degrees. I would like you to think of these things spatially as much as you can. And once you kind of get the patterns and you start seeing it more, these problems become much, much simpler. But really think about this spatially before you go into trying to get too analytical with some of these things. So let's look at part B. So part B asks us about the sine of 247 degrees. So 247 degrees, we need to understand, well, where is that? So we start off, we draw where 247 is going to be. Well, it's going to be about down here. So we know that sine is all related to its y value. It's all related to its y value. So this down here, we have a negative y value. So we're going to have a negative sine. Well, if we go to the other side of the circle, that's going to put us, or the other side of our line, this puts us up into the first quadrant, which is what we want, right? So how do we judge both of these things the same? Now, it's really easy to judge these based off of, because we want an angle that goes this way. So what angle, or where can I draw an angle to make the same amount of distance that I just drew with that little white arrow? Well, it looks like it would be moved symmetrically that way, if you see what I'm saying. So this is 180 and 0. So if I move up from 0 or forward from 180, what happens to my value of sine? So these sines on these different sides of the circle are actually opposite, right? They're on the opposite sides of our line. They're opposites. So what I need to understand first is, well, The sine of 247, I can think of that as the sine of 180 degrees plus 67 degrees, right? So this line here is 67 degrees. That's the same thing as that line. So what's going to happen is that this is going to become the opposite of the sine of 67 degrees. Now notice I've got an angle that is acute. See, this ended up giving me the opposite answer as well. So, trying to fit it in here, because the signs are always positive in the first quadrant, and they're always negative in the bottom. So I know that it's going to have to be the opposites, but how do they relate is really the key that I'm trying to figure out. So getting that little spatial awareness will very, very much help. So let's look at some other stuff. So 6 gives us the cosine, and I'm just going to erase the tangent part. 6 gives us the cosine of 320 degrees. So this becomes a little more interesting. So we got 320 degrees. Well, where is 320 degrees at? That is over here, right? It's not quite to 360, but it's close. So what we want to figure out is, okay, well, what cosine only depends on its x value. So how could I figure out the same x value, but in the first quadrant? Well, x values kind of go up, straight up and down. They're the same that way. So if I were to figure out, okay, so this is going to have also a positive x. Well, what do they have in common? That's what we need to be asking ourselves. What do they have in common, and how can I kind of relate the two of them together? Well, they seem to be the same distance off of 0. Or remember that 0 is the same thing as 360. So what I could say here is this is the same thing as the cosine of 360 degrees minus, 40? So if I go back 40 from 360, that gives me the same value as the cosine of 40 degrees, right? Because they have the same x-coordinate. They're going to end up having the same cosine. Whether or not I go backwards or forwards from 360, it doesn't matter. I end up with the same value. So being able to see where it is and how it relates and what coordinate does it matter with, that's going to really help you understand trig. So always start off thinking about where it is and how does it relate to some other things. Is it going to be a large value, a small value? Is it going to be negative or positive? These are all the things that we need to consider in this unit.